Hello students, welcome to Eduxcite classes. In today's session, we will solve topic 6, circular motion and gravitation as well of paper 1 past year MCQ. Okay, so without wasting time, let us start. So there are 2 points P and Q whose radius are R, L, 2R given to us, which are moving on a circular disc whose center is X. So point P has a linear speed v. Now we know that linear speed depends on what? 2 pi r by t. Okay, and centripetal acceleration a. So centripetal acceleration a is v square by r. So which of the following is correct for Q? Now when we say for Q, now both are rotating on the same disk, so the time period is same. So for VQ it will be 2 pi times 2r by t. So it will be 2 times of V. Okay, so A and B are incorrect. Now for A will be what? V square, so it will be 2V square by R. So R is again 2R. So it will be 4V square by 2R. So this become 2V square by R, which is 2 times of A. So option C is the right answer. Okay. Now question number 2. The point P is moving in a circular with uniform speed, guys. Now whenever an object is moving with a uniform speed in a uniform circular motion, which one of the following diagram correctly show the direction of the acceleration A and the velocity v of the particle? Now it is the most fundamental characteristics of any object moving in a circular that the acceleration and the velocity component are both perpendicular to each other. Also it will be towards the center, and this will be tangential with it touches the circle at a single point. So you just check, this is incorrect, this is tangential, so incorrect, this is also incorrect. So option C is the right answer. Okay, very easy. Question number 3. The centripetal force that causes a car to go round a bend in a road is provided by. So whenever an car, okay, let us say this is my car, which is moving in this direction. So here always the force which act towards the center, that is nothing but the centripetal force, is nothing but the friction. So friction is acting towards the center. So in that case, bending the friction provided by the tire and the road, which is option B. Okay. Now question number 4. The centripetal force F is acting on a mass m that is traveling with a linear speed v along a circle of radius r. So we know that F is equals to mv square by r. Option D is the right answer. Very simple. Now question number 5. A disk is being placed on a flat horizontal disk. A disk is rotating at a constant speed about a vertical axis through its center. The brick does not move relative to the disk. Now this is the brick, this is the disk, and this is the vertical, like this is the vertical axis, and the disk is moving like this. Okay, and the brick is kept on a disk. Now we have to correctly represent the horizontal force acting on the brick. Now we know that there will be only one force acting towards the center. Okay, now in that case, that force will be, again it is similar to the bending of the car only. So the friction will be acting towards the center. So that is the only force acting in this case. This is not the case because we do not draw centrifugals. When those who are saying a centrifugal force, I just let you know that that is a pseudo force. Okay, that is just to counterbalance that the concept of Newton's third law, but again that is a question of the frames, the frame in which you are looking for. Anyway, so here only one force is acting, that is the friction, which is the horizontal force acting on the brick. Okay, the horizontal, vertical are again the weight and the normal reaction, but those are the vertical forces, not the horizontal. Now the 6.2, Newton's laws of gravitation. So in Newton's law of gravitation, the masses are assumed to be, again we assume them as a point masses, and we take the distance from the center of those two masses. Okay. Question number 2. Newton's laws of gravitation of the force F between 2 point objects of mass m and small m are separated by a distance d that can be denoted, okay, The expression may also be used for the force of attraction between the sun and the earth, although they are not point masses. This is because, now we can consider, because when we are considering the distances, so distance space, or you can say the separation between the sun and the earth are very large as compared to the size of the planet earth or the sun. So you can say the separation of the earth and the sun is much greater than their radii. Okay, so you can neglify those small distances when you are measuring the forces between sun and the earth. Okay, so the gravitational field strength at a point may be defined as, again guys, many a times it creates a confusion, so you should have a proper clear understanding of the definition of few terms in your IBDP. They have asked many a times. Okay, so we know that gravitational field strength is nothing but the G, so that is nothing but the force per unit mass F by m. Okay, so force per unit mass on a small mass placed at a point. So option B is the right answer. Question number 4. The acceleration of the free fall of the mass is given to you, and the close to the surface is this, the gravitational. Now gravitational field strength is another term of gravitational acceleration. Okay guys, so do not get confused, they are one and the same thing, so no need to calculate it. Acceleration is in meter per second square and gravitational field strength is measured in Newton per kg. So option C, it will be the same. It is asking you the field strength, not the force. Okay, so be very careful. Option C is the right. Now question number 5. The earth is distance rm from the moon and distance rs from the sun. The ratio of gravitational field strength at the earth due to the moon, at the earth due to the sun is proportional. Now it is not asking equivalent to, it is proportional to which of the following in terms of radius. Okay, now we know that G is equals to what? Small g. It is capital G m upon r square. So we can say G of at the earth due to moon. So due to moon is inversely proportional to the distance, that is let us say Gm upon Gs. So it will be inversely proportional. So here it will be Rm square and here it will be Rs square. So you can say it is proportional to Rs square upon Rm square. That is the radius of the sun, the distance of the sun to the moon, sorry, to the earth, and distance of the moon to the earth, the proportion. So option C is the right answer using this equation. Okay, now question number 6. A planet X has a radius r and a mass m, and a planet Y has a radius 2r and mass 8m. Which of the following is correct value of the ratio of gravitational? Now again this will be G mx upon rx square divided by G my upon ry square. Now G and G gets cancelled, so first mx has a mass m, r is the radius r square, so ry is 2r square upon mass of y is 8m. So you just do the calculation, m and m gets cancelled, 2 square is 4r square upon r square into 8, this gets cancelled, this is 1 by 2. So option C is the right answer. I hope you like this. If you have any doubt in any of the question, you just comment below. I will try my level best to answer the particular question. Okay, question number 7. Now this is quite conceptual. Two isolated sphere, it means no other forces are acting on this, so you can consider these as the two isolated spheres of mass capital M and small m are held at a distance d apart. Okay, so this is at a d apart. Mass m is greater than mass small m. Gravitational field strength G is measured on a line between these two masses. Which graph best shows the variation of distance x from the largest sphere of the magnitude of the field strength D? Now we know that magnitude is depending upon Gm upon r square. Okay, now there are two objects, so there will be you can say the gravitational fields will be interacting. Okay, so when it is near to this, definitely the gravitational field strength due to the bigger, because mass is greater, and radius is larger. So you can compare that this at this point the gravitational field strength due to this will be more as compared to that of this. So it is not possible that when at this 2 points when you are moving along the x there will be have same gravitational potential strength at the nearest point to the capital M and small m. So just looking at that also you can say A and B are incorrect, because they are saying that it is the same when it is closer to capital M and closer to small m, which is not possible. Now we have to select for C and D. Okay, now D suggested that it will be 0 at one point. Absolutely it will be 0, because the gravitational field strength is always towards the object of mass m. So one is greater, one is lesser. So there will be, when you are moving along it, there will be a certain point when the gravitational field strength reduces to 0. And if it reduces to 0, then definitely this is not the option. So correct option is D only. So it will be the line will be like this. The gravitational field strength will vary like this. It will have a particular, and again it will be not at in just between, it will be near to this. Then only gm upon this distance, because this is a greater mass, will be equal to where the distance is less. So this gravitational field will cancel this gravitational field strength. Then it will be closer to small m and greater away from capital M. So this is the best option with according to the question. Okay. And the last question, the satellite of mass m and speed v orbits the earth at a distance r from the center of the earth. The gravitational field strength due to the earth at the satellite is equal to. Now we know that gravitational field strength g is nothing but the centripetal acceleration also, which is v square by r. Option B is the right answer. So I hope I have tried to cover the important questions of topic 6, because it is quite very easy and the shortest topic among your DP syllabus. Otherwise also, if you have any doubt, just let me know in the comment below, and you can download the PDF of this video also. The link is given in the description below. All the very best for your exams. Take care. See you in the next video. Keep learning.